general form. And I say quadratics, you know it's a quadratic because one of the things is getting squared. 1x has an exponent of 2. And you know it's general form because there's an x that is being squared and a regular x. And you cannot add these. So have your a, b, and c, and those represent the numbers that are in front of those, in front of the x. Now, if this a is positive, it makes a parabola that opens upwards like this. If it's negative, opens downwards. The b is much more difficult to see from the graph, and then this value is the y-intercept. When x is 0, these will go away, and we would just have this value c. Now, I also drew here the parent graph, and the vertex is this bottommost point where it turns direction. And when you go to graph this, you always find the vertex first, and then the next point to either side is over 1, up 1. The next point after that, if you went instead, you went over 2. I'll put the 2 here. So over 1, up 1, over 2, up 4 because 2 squared. And then after that would be over 3, up 9. And then after that, 16, and so on. So 1, 4, 9, we're going to use those numbers over and over. 1, 4, 9, that's how we find the points from the vertex. The next point's over without doing too much work. Okay, so we're going to use this information to graph this specific equation. Now again, it's quadratic because the exponent is 2, and it's general form because it has an x squared and an x. And you cannot add these together. They're not the right size. This one's getting squared and this one's regular. Now, first off, we're going to find the a, b, and c of this particular quadratic. Now, this one is 1x squared, and nobody ever writes a 1. So a is 1. B, you have to consider the plus is going to the 8. So b is positive 8, and c is 12. So I'm including the plus sign when I look at that. For a minus sign, it'd be different. So we're going to find the vertex, and this is the equation for the x of the vertex. Now, where this comes from will be explained in a later video, but for now, you have to know that there's a small formula here, negative b over 2a, that finds the x of the vertex. So if we use this, b is 8, but there's a minus sign. There's a negative as part of the formula. So when we go to write this, that'd be negative 8 divided by 2 times the a number. So I'm going to go ahead and do that. 2 times a is 2. Negative 8 divided by 2 is negative 4. Okay, that's the x of the vertex. Now, if we're going to find the y, we have to go ahead and plug that back in. So negative 4, negative 1, negative 2, negative 3, negative 4. Somewhere here is where the vertex is. Now, we still need to know the y value. So I'm going to go ahead and plug in negative 4 into both of these x's, and y would equal negative 4 times negative 4 is positive 16. 8, and these are getting multiplied. 8 times negative 4 is negative 32, so I'm going to write minus 32, and then the 12 is plus 12. Okay, so if x equals negative 4, then y equals 16 minus 32 plus 12. Well, that's minus 16. And then if I carry down the 12, that would be negative 4. Okay, negative 4 is the y value. Go ahead and match it up. It'd be right here. And Now, when you go to graph this, the a value is 1, and in most cases it will be. And that means that the next points are going to follow this predictable pattern: over 1 up 1, over 2 up 4, and the next one's over 3 up 9. So 1, 4, 9 is sort of the slope, so to speak. Okay, I've got my parent graph sketched in the corner up here. I'm going to use this pattern. And then we just figured out vertex is -4, -4. And so I got my x, y, here's 0. This is going to count by ones. And so -4, -4, -4 here. That's going to be the vertex. I'm going to put V for vertex. -4, -4. Okay, we're going to use this pattern over 1. So from the vertex, it's been shifted, but we're going to go over 1 up 1. And then from the vertex to 4. And then the next one, 3, 9. And now just to show you that 12 is in fact the vertex, the next one that's not shown over here would be 4, 16, because that's 4 times 4. And so if we go over 4, up 16 to 4. 16 is right here from the vertex, but that's actually point 012 in xy. Now I'm going to go ahead and match that up over here. It's all symmetrical. And let's go ahead and sketch in the in-between points as best we can. It makes a nice round curve here. And it will keep going up forever. So I put the arrows on the end here, and the same happens on this side. Keep going forever. Okay, now the other important points that we should know about are these two. So we know the y-intercept, that's this one. The x-intercept is these two places, and we call those the roots. It's the roots of the parabola. This one is at 2, -2, I mean, 0. And this one is at 3, 4, 5, 6, -6, 0. And so those, the vertex, the roots, and the y-intercept, those are the most important points on this graph. We always go ahead and find those when we do these graphing.